Hello, good day everyone. I welcome you back to this channel with Islamic greetings. Assalamu alaikum wa rahmatullahi wa barakatuh. So here we have another interesting topic, which is the theory of logarithm. But this aspect of logarithm is going to be strictly focused on the laws of logarithm, not the logarithm of number less than 1 or greater than 1, because this is going to show the relationship between the logarithm and indices. So it's going to strictly focus on the laws of logarithm, not the other one of logarithm of number less than 1 or greater than 1. So in this case, we don't need any table. Okay, so let's proceed. Now, before I start with the laws, I would like to give a brief introduction of how indices and logarithms are related. Okay, let's take for instance, we have something like this. If a raised to power x is equals to b, and we want to find the value of x. Now, if you look at this expression clearly, you have a as a base here and you have b as a base here. They are not of the same base and want to find this value of x. For you to express that, focus on the base that have the unknown. The base that have the unknown here is simply base a. So since this base a, you are expected to log both sides of that equation to base a. Now I'm going to have something like this now. If I do that, log in base a, that's a base a, then the whole of this, you write it a raised to power x, then would be equals to log again in base a, then this number. So when you have something like this, of which you have, I usually call it the power law, or you call it three-step law. We are still coming there. 1, 2, 3. The last power, which is this x here, take it to the back of that log. That will be x log in base a, that's a in base a, is equals to log b in base a. Now, this one here, one of the laws of logarithm is that if you have the base and the number to be the same thing, just like what we have here, you can see we have a as our base and the number is also a. The law is whenever you have the number to be the same thing as the base, log a in base a will be equals to 1. Similarly, if I have log b in base b, it will be equals to 1. It's just like saying whenever you have the base to be the same thing as the number, the answer is equals to 1. So here we are going to have x multiplied by 1 is equals to log b in base a. So here we have x to be equals to log b in base a. So that is how to express this, and that shows the relationship between indices and logarithm. Are you clear with that? Okay, but remember something, that general form of which you can express logarithm as is base 10. General form is base 10. So let's start with the first law. Now the first law we have, let's say we have log m plus log n. As you can see, there is nothing here at the base of that log. Whenever you have an expression like this of which the base are not having anything, it is simply the same thing as saying that log is in base 10. Same thing. That is, log like this is the same thing as saying log in base 10. Whether there is 10 there or not, just know that it is base 10. Okay, that's one of the laws. Okay. Now, since this and this are having the same base, which is base 10, we can simply take one of the log out. That is in base 10. Then we have m. The law is we now have m multiplying what? N. That is, addition changes to multiplication. So this will give us log m n. Can you see that? Whether the answer can look like this or you can show the base. Either of the two is correct. Do you understand that? So the law here is if you have addition of which the base are the same thing, base of that log are the same thing, the number will be multiplied together. The addition changes to multiplication. That's the law. So let's look at the second law, another law. Now, I'm still using the same number. Let's say log m minus log n. The base are the same. So you bring one base out, same thing as base 10. Then you have m divided by n. So the law here is that if you have a minus sign between two logarithms of which the base are the same, the minus sign will change to division, which is why we have m over what? N. And this is also the same thing as showing that base 10 then does not change the numbers. Okay, so they are the same thing. Let's take another law. So the law here is, let's say you want to express something like this, m then raised to the power of n. Don't forget, this is similarly to this. but the base here is base 10. Same thing. So just take the power, the last power, take it. This is what they call power law of logarithm. You take this last, the power of that number, which is n, take it to the back of that log. You have n log m. And this one, don't forget, is same thing as n log m by showing the base 10. Same thing. So let's look at another law. This is just very simple. It's just a very simple law, okay? Let's take, for instance, we have log m all raised to power 0 plus log n all raised to power 0. You can see. Now, this is bracket. There's a bracket here. This bracket indicates that everything inside there is raised to power of 0. This also always raised to power of 0. So according to law of logarithm, same thing as law of indices. We have done that in previous videos on indices. According to the laws, anything raised to power 0 is simply equals to 1. So that means that this one is equals to 1 plus this one is also equals to 1. So the result here is going to be what? 2. So these are the basic laws you need to solve any questions on the theory of logarithm based on the laws of logarithm. Solve any problems on logarithm. Okay, these are the simple laws that you need. So in my subsequent video, we are going to look at calculation on this, on every law here, how we can express questions on logarithm. So if you enjoyed this video, kindly give this video a like, turn on the bell notification, and share this video to your colleagues. Don't forget to subscribe, like, share. I'll see you guys in the next one. Bye for now.